Hello, my dear friends. I am Dr. Gayal Baliram Sambhaji, working as an assistant professor in the Department of Electronics and Telecommunication Engineering, RMD Singer School of Engineering, Pune. Now, today's topic of discussion is a digital logic gate and integrated circuits. Now, digital logic gates are the fundamental building blocks of digital system which performing basic logical operation. So we can consider logical operation as and or not uh, on one or more binary inputs and which produces a single output. For example, here we consider this is a OR gate. This is a symbol of OR gate. We applied A and B as a input where Y is the output and that Boolean expression for this Y is equal to A plus B. This transistor-based circuit process signal as high or low means 1 and 0 voltage levels, forming the basis of all modern digital electronics. Now, that modern digital electronics we are using, such as digital calculators, digital clocks, digital cameras, cell phones, modern computers, and laptops, as you know. Now, what is meant by that integrated circuit? That integrated circuits here are the chips or piece of semiconductor material that contain all of the transistor, resistor, diode, capacitor necessary to create a digital circuit or a digital system. And in this diagram shown, you may come across such type of integrated circuit that is called as a ICs. Okay. Now we know that firstly that logic gate such a number of logic gate accommodated in on a single chip or that is a semiconductor that forms a IC. And when such electronic circuit and such integrated or ICs mounted on this PCB that are called as a digital circuits and like that. Now types of digital gates. Logic gates. Now we classify broadly that logic gates as basic gates, universal gate, and special purpose gate. Basic gates are called basic because using these gates, basic gates, we can form any type of circuit, digital circuits. And that are the basic gates are OR gate, AND gate, and NOT gate. Universal gate. Why these gates are called as universal? Because using any one of these universal gate, there are two types of universal gate. One is a NAND gate, another one is a NOR gate. Using any one, we can build or we can form that any digital logic circuits. And that third type is a special purpose gates and that are XOR and XNOR gates. Now let us see one by one the OR gate. Now this is a ANDing operation in short, which we know. Now this is a symbol for that OR gate, which having A and B as an input and X as an output. And this X is equal to A plus B, that is a ORing operation. That is a ORing operation means that is a addition. And this is a law called as a logical expression for that. And truth table here in that truth table we are having input and output. Input we have to consider possible number of inputs we can apply to that gates or that digital circuits. Now here there are two inputs means we are having 2 raised to n possible inputs means 4 inputs here. 2 raised to 2 means 4. That is what we can apply 0 0 0 1 1 0 and 1 1 means when we apply 0 0 as the input to this OR gate that gives us output 0. When we apply 0 1 output is 1. When we apply 1 0 that output is 1. Then when we apply 1 1 means A and B as a 1 1 then output is 1. That is a ANDing, that is we can say that addition or that is a OR operation. Now ICs for this, that IC number, we are having two types of IC, TTL logic IC and CMOS logic IC. Now here TTL logic IC is a 7432 that is a OR gate IC. Now it is a 14 pin IC. Okay, and here that 7 pin is a ground, 14 pin is a VCC, and here remaining pins we are connected to that gates. For pin number 1 and 2 connected to that OR gate as a input, first OR gate, and 3 pin is output. Then 4 and 5 consider connected as a input to that second OR gate, 6 is output. Likewise here reverse. Here for third 8 pin is a output and 9, 10 are the input. For fourth OR gate, that 11 is a pin is output and this 12 and 30 are the inputs. Now here in this second diagram shown, that is CMOS logic. That is IC number 407. It is again a 14 pins, 7 is a ground, 14 is a VDD, and it can accommodate such a 4 OR gates. And this is a physical appearance of that IC, that is a OR gate IC 7432. Now, second is a AND gate. AND gate, it is it is a simple multiplication operation. We can say that this is a symbol for this, which having A and B as an input, Y is the output. This is a logical expression for that. That is a Y is equal to A and B. And what is a truth table? Truth table gives us a operation of this logic gate. Whenever we apply input, what will be the output? Now here we are having two input A and B, means here what are the possible combination? For possible combination 0, 0, 0, 1, 1, 0, 1, 1 as usual. And when we apply 0, 0 input, that gives us a output 0. This is a multiplication operation. 0, 1 output is 0, 1, 0 output is 0, 1, 1 output is 1. Then here IC structure for this, that IC in TTL IC number is 7408. As usual, it is a 14 pin IC, 7 is a ground, 14 is a VCC. It can accommodate here 4 AND gate. 1, 2 as a input to that first gate, 3 is output. 4, 5 input, 6 is output. Here 8 is the output and 9, 10 is the input to that third gate. 11 is the output, 12, 30 is the input to that fourth, that is the AND gate. And here this is a 4081 is a CMOS logic IC of that AND gate. And this is a physical IC structure or appearance of that. Now, third is a NOT gate. This is a basic gate again. Only one difference is here, it having only one input and one out. And here's note this bubble. Bubble gives us that NOT or complement operation, we can say that here. Whatever we applied as the input, that gives us a complement of that as output. This is a symbol for that. A is the input, Y is the output. Logical expression or Boolean expression for that, Y is equal to A bar, means that is a not A, or that is a complement of input. And here truth table, when we apply 0, output will be 1. When we apply 1, output will be 0. Then IC structure for this NOT gate. Again, it is a 14 pin IC, 7 is a ground, 14 is a VCC. And here, as we know, that having one input and one output, means here it can accommodate in this way, that is a 6 NOT gate. Okay. Then this is a CMOS logic IC for this NOT gate, that is a 4069. This is a physical appearance of this. Then universal gate. Okay, we know that NAND and NOR we call as a universal gate. Now NAND gate, this is a symbol of that NAND gate, means it is a complement of that AND, we can say that. Here A and B is the input, Y is output, and note here bubble. Okay, now here Boolean expression for this, Y is equal to that is output A dot B of that bar, means AND operation, and its bar or complement, that is a NAND operation. And here input, when we apply 0, 0, output will be 1, 0, 1, output will be 1, 1, 0 applied, output will be 1, and when we apply 1, 1, output will be 0. Then IC number for this is 7400. Again, it is a 14 pin IC as usual. 1, 2 as the input, 3 is the output, then 4, 5 is the input to that gate, 6 is the output, 8 is output, 9, 10 is the input, 11 here output, and 12, 30 is the input. and IC number of that TTL logic IC is a 7400 and CMOS is a 4011 and is a physical appearance of this IC. Then NOR gate, it is again a universal logic gate. This is a symbol for that. It is similar to that NOT gate, but note here, there is a bubble at the output side. As usual, it having A and B is the input, X is the output. Logical expression for this, X is equal to A plus B means that our operation is complement. And this truth table, it gives us a functioning of this NOR gate. When we apply, as usual, that having two inputs means we are having four possible output. We can apply four possible input and corresponding to that only one output. Means what are that input we can apply? 0, 0, output will be 1, 0, 1, output is 0, 1, 0, output is 0, 1, 1, output will be 0. Then IC number, TTL IC number for this 7402 for this NOT gate. It is again a 14 pin IC, 7 is a ground, 14 is a VCC, and this is a input output relations. Then this is a CMOS logic, and it is again 14, 7 is a ground, 14 is a VDD, and IC number is 4001. This is a physical appearance of this IC 74LS02, that is a NOR gate. Then XOR gate, this gate is a special type of gate. Okay, and this is a symbol for that, 2 input, 1 output, and here that operation denoted plus sign, and there is a circle around that. And output, here again we are having 2 inputs means 4 possible input we can apply, 0, 0, 0, 1, 1, 0, 1, 1, and corresponding to that we are having output whenever there is a dissimilar input, means we can say that 0, 1 and 1, 0. At that time it gives us a high output, and for similar input that output remains low, that is a 0, 0. This is a XOR gate, and this is a IC TTL logic IC of this XOR gate, that is a 7486. It is again a 14 pin IC. 1, 2 is the input, 3 is the output, 4, 5 is the input, 6 is output, 8 is output, 9, 10 is the input, 11 is output, 12, 30 is the input to that fourth gate. And this is a CMOS logic. That number is 4030. It is again 14 pin, ground 7, VDD 14, and it accommodates 4 XOR gate. And this is a physical appearance of that ICs. Then XNOR gate. This is a symbol for that. It is a complement of that XOR. Okay, that A XOR B, its complement, that is a XNOR. This is a symbol for that. Operation will be complement of that previous. As usual, that having 2 inputs means 4 different possible combination, 0, 0, 0, 1, 1, 0, 1, 1. Whenever we are having similar input, it gives us output high, means 0, 0, output is 1, 1, 1, output is 1. And for dissimilar input, it gives us output 0, means dissimilar input means that is 0, 1, output is 0, 1, 0, output is 0. And this is a IC structure, TTL logic IC, number is 74266. This is again 14 pin. Again, it can accommodate 4 XNOR ICs, that gate here in that single IC. And this is a CMOS logic, that IC number is 4077. Again, it is a 14 pin. 7 is a ground, 14 is a VDD, and it can accommodate 4 that gates that are the XNOR gate. And this is a physical appearance of that XNOR gate. Now again, that having multiple input ICs also. For example, we consider this is a NAND gate 74LS00, that having 2 input, 74LS10, that is a 3 input NAND gate, 7420, that is a 4 input NAND gate, and 7430, that is a 8 input NAND gate. In this way, similarly. Now here, depending upon how many number of gates accommodated in a single IC to form that that particular type of IC, based on that we can classify that small scale integration, medium scale integration, large scale integration.